project is VLC, that is Visible Light Communication. VLC is a communication technology where we use a light source, that is LED, to transmit data, air as a medium, and a receiver, that is a photodiode, at the other end. In this manner, what we can do is we can serve the dual purpose of illuminating an entire room as well as transmission of data.
Now I'm going to talk about the different types of components from TI what we have used for our visible light communication project. First is LM358 IC, which is this one. It is a general purpose op-amp which has two op-amps in it. It is used in the receiver part for digitizing the analog signal received from the photodiode. Next I'm speaking is LM324 IC, which is similar to the LM358 IC, but it has 4 op-amps in it. Next, I'm going to talk about MSP430G2 microcontroller from Texas Instruments, which is this one. It is used at the transmitter as well as the receiver end to transmit data and to receive data via UART protocol from the source.
Now we come to the block diagram part, which is made up of the transmitter and the receiver. The transmitter is made up of two sources, the MSP430 boards and the LED drivers. The source 1 and source 2 will basically be an information signal that can vary from audio, text or image, which will be passed on to the MSP430s using a UART protocol. The MSP430s will process the data and convert it into digital form, that is ones and zeros, which will be used for intensity modulation of your LEDs. The LED drivers will increase the intensity of light of these LEDs. Air will be the medium of transmission, and now we come to the receiver part. The receiver part is made up of the lens assembly, the optical filters, that is the cellophane papers, the photodiode, comparators, the MSP430s, and the receiver screen. The lens assembly will help us in focusing the light coming from the LEDs onto the photodiodes, while the red and the blue cellophane papers will help us in separating the light from both the LEDs, that is the blue and the red, which will be in turn the analog value, analog signal from the photodiode is passed on to the comparator, which will convert it to digital form, which is in turn given to the MSP430, which will give back our original data and will be displayed onto the screen.
Here we see the basic components which form the transmitter and receiver sections. The transmitter components were assembled and packaged inside the transmitter block shown in the figure. The receiver block shown here envelops the assembled receiver components. The experimental setup is shown next. Here the transmitter and receiver blocks communicate information over a distance of approximately 1 meter. The transmitter contains a pair of red LEDs and a pair of blue LEDs. The combined illumination of both the LED pairs makes the transmitter's output appear to have a pinkish glow. The red LEDs convey text that says Visible Light Communication, while the blue LED pair conveys Texas Instruments MSP430G2. The experimental setup can convey any text string as long as the individual characters that make up the text are valid ASCII characters. The receiver's lens assembly captures light over a wide area and focuses it onto tiny receivers after passing it through 2 optical filters, as explained previously in the block diagram section. The recovered text data is then displayed on the computer's serial terminals.
Next, we move to the VLC potential application. First is vehicular communication. In this, the vehicles and the traffic light systems incorporated with the VLC systems would retrieve some form of information between each other. This information may be about the local traffic or even direction to a specific location. Second, in hospitals, visible light is well suited for communication in hospitals, especially around MRI scanners in operating theaters where RF radiations are undesirable. Third, Underwater communication. Till now, divers use sign language to communicate between each other underwater. So by using light source which they carry for proper direction can itself be incorporated with VRC system for voice-to-voice communication. Fourth, area sensitive to radio waves. Where such radiations can lead to fire or any kind of devastation, visible light communication in such areas will be much more safer. Fifth is smart lighting. This is more of a future scope of VRC system, wherein from taking a print from a printer to accessing internet is done through light.